Hi and welcome to this video in which we're going to be going through AQA Physics P3 paper from Monday 19th May 2014. So let's take a look at question 1. What is ultrasound? It is sound with a frequency above 20,000 Hertz or 20 kilohertz. Figure 1 shows how ultrasound is used to measure the depth of water below a ship. A pulse of ultrasound is sent out from an electronic system on board the ship. It takes 0.8 seconds for the emitted ultrasound to be received back at the ship. Calculate the depth of the water. The speed of ultrasound in water is 1,600 meters per second. So we know that speed is distance divided by time. So the distance that it's travelled must be speed times time. So 1,600 times 0.8, which gives us 1,280 meters. But that's the distance to go to the bottom of the seabed and back again. So we need to divide that by 2 to get a depth of 640 meters. Ultrasound can be used in medicine for scanning. State one medical use of ultrasound scanning. Well, the one that everyone knows there is fetal scanning. Pregnancy scans would get the mark as well. Images of the inside of the human body can be made using a computerized tomography scanner, CT scanner. The CT scanner in figure 2 uses X-rays to produce these images. State one advantage and one disadvantage of using a CT scanner compared with ultrasound scanning for forming images inside of the human body. So the main advantage of CT scanning compared to ultrasound is that it has a higher resolution image. That means we can see more detail. The main disadvantage of CT scanning is it produces ionizing radiation. Which is a problem because that can cause mutations and lead to cancer. Question 2. Man-made satellites can orbit the Earth as shown in figure 3. The satellite experiences a resultant force directed towards the centre of the orbit. This resultant force is called the centripetal force. What provides the centripetal force on the satellite? In this case, that will be gravity. State two factors that determine the size of the centripetal force on the satellite. So the first one is the mass of the satellite. And the second one we're going to go for is radius of orbit. The other thing that would have an impact would be the velocity of the satellite. Okay, table 1 gives data for 5 different satellites orbiting the Earth. State the relationship, if any, between the height of the satellite, so this column, and the time taken, which is this column. So as the height increases, the time taken increases. For the next part, it asks us to state the relationship, if any, between the time taken for the satellite to orbit the Earth once and the satellite's mass. So we see that that column goes up, but the mass of the satellite kind of goes down and then up and then down and up. There's no relationship. Over 300 years ago, the famous scientist Isaac Newton proposed the thought experiment, the idea of satellites. Newton suggested that if an object was fired at the right speed from the top of a high mountain, it would circle the Earth. Why did many people accept Isaac Newton's idea as being possible? So all of these things are true, but the reason that Isaac Newton's idea was accepted was the first one, because he was a respected scientist who had made new discoveries before. Okay, 6 marker. There are 2 types of transformer, step up and step down. Describe the similarities and differences between a step up transformer and a step down transformer. You should include details of construction, including materials used, and the effect it has on the input potential difference. So let's start with something that they've got in common. Both transformers have a soft iron core. They both have insulated wire wrapped around them to make the primary and secondary coils. Okay, so there's the key part of the structure. Differences now. So step up transformers have more turns on the secondary coil than on the primary. So the output PD is greater than the input. And then the opposite's true for step down. Step down transformers have fewer turns on the secondary coil. So the output PD is smaller than the input. You know, it doesn't ask us for any information about how they work, so we're not going to include that. We should have 6 marks there. Figure 4 shows a mobile phone and charger. Mobile phone chargers use a different type of transformer, which is smaller and lighter than a traditional transformer. What name is given to this transformer? It is a switch mode transformer. Question 4. Figure 5 shows a girl standing on a diving board. Calculate the total clockwise moment of the weight of the diving board and the weight of the girl about point A and give the unit. So, the total moment is going to equal the moment of the girl plus the moment of the board. So the moment of the girl is going to be her weight times the distance from the pivot, 600 times 3. And the moment of the board is going to be its weight times the distance from the pivot. Which gives us in total 3,800. And we want to give the unit, which is Newton meters. Capital N, little m. Figure 6 shows the girl standing at different places on the diving board. The support provides an upward force to keep the diving board balanced. Figure 7 shows how the upward force varies with the distance of the girl from point A. Explain in terms of clockwise and anti-clockwise moments why the upward force increases as shown in figure 7. Explain in terms of clockwise and anti-clockwise why the upward force F increases as shown in figure 7. As the girl gets further from the pivot, the clockwise moment increases. For the board to be balanced, the clockwise moment must be equalled by the anti-clockwise moment, so the anti-clockwise moment must also get bigger. The distance of F is constant, so F must get larger. Okay, that's probably more information than we needed, but we're going to be sure that we've got all the points in that answer. Okay. Question 5a, human eyes and digital cameras both have parts with the same function. What are the comparative parts? So they've given us an example. The thing that refracts light produces an image. In the eye is the cornea and lens, and in the digital camera is just the lens. Images are focused here. So we're told that it's the retina in the eye. In a digital camera, it's a CCD. If it's an old-fashioned camera, it's on some film. A variable opening where light enters. In the digital camera is the aperture, and on your eye is the pupil. Long sight is a defect of the human eye, so give two causes of long sight. So the first one is that the eyeball is too short. Or the other one is that the lens isn't powerful enough. Because what's happening in long sight is the image is focused behind the back of the retina, because the lens hasn't bent it enough for the rays to focus on the retina. Long sight can be corrected by wearing spectacles with converging convex lenses. A lens in these spectacles has a power of plus 3.2 diopters. Calculate the focal length of this lens. So the equation that we need is P is equal to 1 over F. So F is equal to 1 over P, 1 over 3.2 is 0.3125, so 31.25 centimetres. Figure 8 shows a ray of light passing through a converging lens, and we've got the angles on there. Use the information to calculate the refractive index of the glass used to make the lens. So the equation we need here is N is sine theta I, the angle of incidence, divided by sine theta R, which is the angle of refraction. So sine 30 over sine 21. You need to make sure your calculator's in degrees to do this. And that gives me an answer of 1.39, so we'll call that 1.4. Different lenses of the same power can be made using glass of different refractive index. What is one advantage of making spectacles using glasses made of a higher refractive index? Well, the advantage of that is we can make them thinner to achieve the same effect. Figure 9 shows a sheet of card. Describe how to find the centre of mass of this sheet of cards. You can draw diagrams as part of your answer. So the first thing we want to do is suspend the card from a point. And we want to suspend a plumb line from the same point. A plumb line is just a piece of string with a mass on the end. And we're going to use that plumb line to draw a line vertically downwards. We then want to suspend the card from a second point. And we're going to draw another line, again vertically downwards. And the centre of mass is where the two lines cross. Oh, I could have drawn a diagram to go with that, but my diagrams are so terrible that it's probably not worthwhile. Okay, there is a person in his wheelchair. Tipping the wheelchair at a large angle may cause it to become unstable and to topple over. Explain why. Okay, so the key 2 points for any answer that says, why does the thing topple over? The line of action of the weight is beyond the base. And as a result of that, there is a resultant moment, or a non-zero resultant moment. Sometimes you get the mark for saying that it's no longer in equilibrium, but talking about resultant moment is more likely to get you the mark. Some disabled athletes use a wheelchair in sports. State 2 ways of changing the design of the wheelchair so that it is more stable. So we could use a wider base and a lower centre of mass. Again, those 2 points are worth remembering because they quite often ask about making something more stable. Figure 11 shows how a ray of light from a laser travels along an optical fibre. Why does the ray of light stay within the optical fibre? That's because of total internal reflection. And if you're too lazy to write that out, you can just write TIR. The material used to make the optical fibre has a refractive index of 1.5. Calculate the critical angle. So the equation is N is 1 over sine theta C. So sine theta C is going to be equal to 1 over 1.5. Which tells me that sine theta C is equal to 0.67. And then if I do the inverse sine of that, I get my angle as 41.8 degrees. Different wavelengths of light can be used to transmit information along an optical fibre. Figure 12 shows how the percentage of incident light transmitted through a fibre varies with wavelength and length of the fibre. Compare the percentages of incident light transmitted through the two different fibres over the range of wavelengths shown. So, let's start with giving the general pattern. As wavelength increases, the percentage of light transmitted decreases, then increases. Okay, then we can see that the minimum is at 5.0 times 10 to the minus 7 meters for both fibers. The longer fiber has a lower percentage of light transmitted at all wavelengths. Musicians sometimes perform on a moving platform. Figure 13 shows the parts of the lifting machine used to move the platform up and down. What type of system uses a liquid to transmit a force? That's called a hydraulic system. The pump creates pressure in the liquid of 8.75 by 10 to the 4 pascals to move the platform upwards. Calculate the force that the liquid applies to the piston. So, the equation tells us that pressure is force over area. So we're after force. So force is pressure times area, which is 8.75 times 10 to the 4 times 1.76 times 10 to the minus 2. So you need to be happy with putting this type of number into your calculator, and if you're not, ask your teacher. And that gives me an answer of 1,540. Be very careful to make sure you write the right number down. The liquid that's usually used in the machine is made by processing oil from underground wells. A new development is to use plant oil as the liquid. Extracting plant oil requires less energy than extracting oil from underground wells. What is an environmental advantage of using plant oil? Okay, so using plant oil, we're not going to burn the oil in this situation, so we can't talk about carbon dioxide and pollution. But what we don't need to do is we don't need to mine for the oil. Musicians often use loudspeakers. Figure 14 shows how a loudspeaker is constructed. The loudspeaker cone vibrates when an alternating current flows through the cone. Explain why. So, when the AC current flows, it creates an alternating magnetic field around the coil. The word alternating is important. They've told you that it's an alternating current supply for a reason, so use that alternating again in the magnetic field. This interacts with the permanent magnet and causes a force. No, let's go with an alternating force. On the wire. This in turn causes the speaker cone to move backwards and forwards. And that's it. Thank you for listening, and I hope that was helpful.